that it will help everybody,
Yeah,
hopefully.
thank you,
Yeah.
Raja.
So
Let's
Christian, go
let's
ahead.
start.
Yes.
Yeah, so the main thing I was saying is basically that I try to get through a couple of my past years' contacts on ResearchGate with I'm in one-on-one communication with, and show them in a A4 summary what we're doing at Text in general, what I'm doing in special, because I'm writing to him with the iSpace stuff. And I've recently, I haven't told you that yet, got very, very positive feedback from specific people on ResearchGate in a peer-to-peer communication. Not officially, not they are posting comments on my papers or so like we typically do with each other, but they are very interested, deeply interested now in the geometry of the charge, with it could be golden ratio native, and why the mass should be discrete, and how all that works together. And just for the audience who just jump into the recording right now, iSpace theory is able to calculate exact value and integer geometry of constants of nature for about 50 constants. And the current physical mainstream, which was recently commented by also an important long-term contender to a comment of mine I made on other papers, is that it is breakthrough style to be able to calculate constants of nature, because most people are not aware even that that is possible, let alone on ResearchGate. Even outside in mainstream, they of course don't know. They measure, they take data value and be happy with whatever is written there, because they don't care about constants of nature. But inside ResearchGate, a lot of from the area of string theory, quantum mechanics, and relativity alike have discussed with me and said what could be, what could not be, and why. And most of the could not be, I can what is the English proper word for that? I can tell them why they were wrong thinking it could not be. Yeah? So I showed them that their assumptions were wrong, not their conclusions. They do the right conclusions under the assumption of their knowledge of mainstream, but the knowledge of mainstream is incomplete. And when you add the iSpace geometry and multiplicative logic to the thinking, then the next conclusion you do, if you're not an aggressive moron in the sense of everything is wrong what you say, I don't listen to you, but this is not a discussion. The discussion needs to be open. And an open discussion needs, if you give you new facts, you please think again, and then you tell what you told me last time. And if you're still thinking, then you have to better argue than before why it's still not working. Especially from the end of relativity, there comes a hard end of why everything needs to be continuum. But the best proof that continuum and integer goes perfectly together is Gert's theory and my theory are 100% value compatible, and that is never an accident, never. So we need to write a joint paper, Gerd and me, on exactly what that this is the case and why that is the case, and bring it through peer review. And even if that is a mild, knowledgeable paper mill, in the sense it doesn't need to be nature, yeah, but it needs to be at least not just a paid one which nobody reads in the sense, but a really a renowned, truly peer-reviewed entity that will get some recognition. Maybe only a couple of 200 people. So that is about what Emmanuel and me got from the reads. We can see that in the ResearchGate reads, when these people from outside come, not from ResearchGate, and see this because there was a peer review somewhere. And this peer review links to the ResearchGate side and from the outside. And many of these researchers outside of ResearchGate have no ResearchGate account. They are not able to promote, they're not able to vote, they're not able to do anything, but they are able to click and look what it is about. And after the peer review, there was a spike in a generation of interest to this paper which I wrote with Emmanuel. And that led to the reputation count in ResearchGate. I think this is risk count, ResearchGate interest score, so it's called technically, of I think 79.5 by now, and that is massive. I didn't know that this is such massive. I hadn't had a big look on that, but this is about 99% higher interest score than any paper published in 2023 at the time when we did that. Or was it 2022? I have to look. and is 97% higher than any paper ever on the time of ResearchGate. This is just amazing. I mean, I think I'm a hobbyist, okay? We just wrote a little bit for the writing of the paper took us 3 days. Actually, the most hard work of publishing was done by Emmanuel, but we wrote literally 50% him, 50% me about. And we wrote it very fast, and the impact was such massive for 3 days of work. So I think this can be repeated. That can be repeated. But we should more and more come to that, publish that what we already know and given for granted, because we don't publish that because we know it's correct. But the others don't know that. And there is still amazing what the rest of the world in mainstream is not knowing. This is shocking to me, because you would think that the people read newspaper or Spektrum der Wissenschaft or Scientific American at least, that they get a little bit idea. But I know more about experiments proving certain things of discreteness than these people in doctor degree level doing everyday research. They should know that as well, and they don't. And when they argue, hey, this is not possible because of blah, 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 I said, look, the neutron made a double slit experiment. The neutron was in 2 paths parallel at the same time over 5 meters. And that is peer-reviewed, world-class, Nobel-style experimental result. And you tell me you don't know that. Now come on and reread. And I sent him a link. And the next day it came back in the ResearchGate post. Oh yeah, now I see what you mean. Now, this is really interesting. So I'm not the trainer of physicists outside of ResearchGate, okay? So we need to find a way to go ballistic beyond the point of interest. And now, how does that typically work with revolutions? When you plan a revolution and not an evolution, you need a hype. And a hype is a technical construction which people like Donald Trump know very well how to generate. And I can tell you how that works, because it is scientifically known how it works. And I read a little bit about it. So what you need to do is bring 10% of the people in a certain group on your side. That would not mean that we need 10% of all scientists on the world on your side, 10% in a certain group which is active. 10% in text is not so much, so this is not what I'm talking about. What I'm talking about is 10% of all people on ResearchGate doing physics. And when you have 10% of these people over a couple of 15 years where massage them on the side where actually he's right, that should not be so easy. Multiplication should not be able to do that. And this is all they need to know. They don't need to say physics in ice space or in gas theory or whatever is right or wrong, but they said it shouldn't be that easy. Let's have a deeper look why that is so easy. And then you win. Because when they start talking about you, you don't need to talk to them to read something. They will come from alone and just read it because they're interested in it. So you need to create the interest. And the interest will be only multiplicative generated when you have 5 or 4 blogging accounts and you're brilliant in blogging. Well, I'm not at all brilliant in blogging. I'm exactly the opposite. So I'm not a press speaker or anything like that. But I'm talented to stay in front of a camera, and I have no problem with that. I'm not at all a press person, okay? I'm a scientific-minded person with a narrow-minded ability to speak at all to a bigger group. Yeah? So I have trained that over my last 40 years, not in the physics business, in the IT business, of course, but nevertheless, this is not what it takes. I'm not a high-profile person sitting in a camera and telling anyone and saying, everybody cheers, yeah, this is exactly what we wanted to hear. So what you need to do is to convince 10 people massively that they are completely convinced that what you do is the future. And they do the all rest. Because once they are convinced, they post every day or every week, look at this text conference, look at this video from Gerd, look at this, look at this, look at this. So they do the little marketing for you. And then a hype crawls up slowly in the sense that people think, what is this about, this Christian talking about ice space all the day? Could that be physics? I say, yeah, if constants of nature are physics, then yes, this is physics. If you think Lego is physics, then no, it's not physics. You have to choose yourself. But to make yourself an image, you please read the paper before you do. And that's the trick. I don't tell anybody to believe in ice space. I tell anybody to think how it could be so easy. And then please read, read, and read. And then trash it. So most discussions on ResearchGate, and Gerd was part of them, that was really fun for it, so he knows best. When we discussed with a Hubble paper of mine, people were discussing that I was a moron scientist, I was a liar, a fake news scientist. So it was really fun. So a certain person, I don't say the name here, was really on doctor degree level, prominently shooting at me with all he had. And it curled up above because I politely but scientifically correct answered to him that he should rethink his arguments over a time of, say, don't know, he go for 3-4 months. And after the 3 months, my paper was raised from about 10 reads to 690. Yeah? And it happened fast. So this guy who says, no, it is all wrong, was the one who did the hype for me. Not the one who think positive on the iSpace. They did no hype for me. It was the one who tried to criticize me to death. And when he always came, I had my running gags answering to him in a way which was just funny. And all the others liked the style because I answered with the same sentence all the time. I said, thank you for helping promote iSpace to become a better known theory by your wrong answers. And I repeated that sentence 200 times. Yeah? And while I was just wanting to leave him off my back, that actually worked. So that, call it a trick, call it an idea, call it whatever. So when people criticize you, be happy as possible, answer politely and repeatedly that he should rethink his arguments because you are absolutely sure it's correct. And whatever was his reasoning for criticizing, he might miss information. Thank you for your input. Yeah? And when you do it like this, you win in the end. You win because all the others looking also at the comments start thinking, what are these guys discussing? This is funny, and have a look. And then they jump by you and tell you, yeah, actually, no, Christian is right. This is not wrong what he's doing. It's no tautology or whatever was the argument at the time. So in the end, we need to find a way to make that not with the conference here as a special case, but with text in general. So what I'm saying is text needs a regular blog, okay? And a regular blog who meets once in a week is probably too much because we don't have the daytime effort. Maybe we should meet only every second week. And in the aftermath of that week, we should take the second weekend to write blogging information instead of talking live. And that blogging information would go to the whole world. And when you have YouTube links, you can get very prominent when you are in a ball run where you say 1 million people click you, then okay, fine, then they know you. But that is difficult and hard way to crawl up. But when you talk about physics and other people in the world point to you and say, yeah, what they said is not completely wrong, there is something to it. And others start discussing over you, and they don't need to look in all the hours of the videos to see what we're talking. So they get just the super nice executive summary on the blog of the week. Not on the day, there's too much work. Sometimes you can blog of the day, of course, but normally it should be regular so that the people get massaged 50 times over a year, typically with some information where they can rely on. This is interesting to read every second weekend. And of course, anybody might take that schema up and have a better idea, but I think this is where we need to go. So our videos are really interesting, but they are too difficult to explain to the average outsider of our discussion groups. It takes too long. Even I went try, Harald, hey, Harald, would you please look the video, look what we discussed there. Harald comes and says, I would love to, I have no time. Give me a 10-line summary what you did there and have a look on a link on a single paper. But this is not realistic that we have a discussion of 3 hours with 5 people, and then someone writes an executive summary of 10 pages and writes a paper of that. So maybe an AI could do that or something in the end, but not right tomorrow, okay? That is something for the future. But we need to learn to market ourselves much better than we currently do. This is what I'm really convinced with. We have tremendous potential, and the theories of Emmanuel of it's superluminality there with the string theoretical thing, where I am saying that is 10-dimensional for good reasons, and string theory, like Christopher says, is 10-dimensional for totally different reasons. And this is all a kind of not who is right and who is wrong. This is a kind of massaging the ones not yet on board. Okay, this is what I try to transport here, and the conference will help. much more than any of the videos would we get press recognition to the keynotes and the events, Emmanuel's papers and so on, in a little summary. Yeah, these guys have written here and here and here, that and that conference. But I was stunned to see that, comma, and then the opinion of the journalist would be summarized in a worldwide readable blog of a science journal, which is to be invited. Yeah, and you can invite anyone, but you need to make him interested enough to travel to Budapest. That's the whole trick. Of course, if that is not possible, it would also be cool if they register and just locally log into the link and then write about that. And this is the minimum deal I want to achieve. So my personal goal is to have 1 or 2 journalists watch from anywhere in the world who I can convince to watch the whole day of the conference, and later write about it. And let's see how far we get. But it's not just Laszlo or me which can pursue that. Any one of you can ask in the private, do you know a journalist, or do you know someone from a newspaper, or do you know anyone who is writing typical science blogs, or have a look at science blogs, summarize them and ask them or inform them just by CC, hint them to the text conference and hint them that the spectacular results what comes there, even if the things are well known for 10 years on ResearchGate. They are spectacular from the outside ResearchGate world. And this is the important to notice difference. We have forgotten how spectacular this stuff is because we work every day with it. We have literally forgotten it. For us, it's normal. It's like, it's cool. We have ice-based theory, but it's not at all cool. This is more than cool. Because would mainstream have such, they would have already exploded to the left and the right at the same time. And we have to make more inroad with the knowledge we have. We have hard times to transport it. That's the point of any scientist, actually. But when I was head of Bürgernetz Landshut, this is a non-profit organization for the internet at the time, I learned from a press-aware guy that he told me in German, I have to translate that, tue Gutes und rede darüber, which means do something well and nicely for everybody, possibly altruistic, and then not just make it happen and watch it, but talk about it, that others see what you did. Yeah. So why would you give altruism for free? The minimum for altruism is not $1 million money, but the minimum for altruism is a press release. And we said, hey, these guys repaired the dirt of a beach. They cleaned the sand in the morning at 5 so that the tourists have a nice beach again, or whatever the activity was. It is not needing to just clean the beach. It is necessary to clean the beach in front of a camera. So this is the big difference, which we really have to learn in an average way to talk about to the average person outside of our own interest circle, what we are doing here, that is important. I'm really convinced we need to do that more. That might need to go to a local university, talk to the local professors and doctors, might need to go to, so this is totally independent of text. Everybody of us can do that every day. Just pick up the phone and call someone and try to reach someone and said, hey, you don't know me. I'm Mr. Christian Wolf. I have a really important thing to tell you from a scientific point of view, where we steal 2 hours of your time. When could we meet?
Yeah, the publicity matters because that gets around. That's a good point. I think this conference will help because it will wake up people. See, I went to I'm teaching in schools also. That's as a guest teacher. So I recently there was a fifth grade, the science, because this is for a teacher. I go and then that day or the couple of days the teacher won't be able to come. So I just continue the lessons they have. But I saw something called, the Newton's law, and they have a project where they put it on a poster and then put different things like the first law and then the inertia and everything, and they have to arrange in a categorical manner, and then say why they are together, why the group is together. So, like 5 different groups of things they write in different cards. It's a simple thing for 5th graders, but that reminded me of the iSpace aspect there. I didn't say, but next time, you know, slowly, I think we can go into the normal physics. That's the idea of these things. It will start diffusing into normal physics. People start understanding it. Normal physics, like philosophers, like the big philosophers, including Popper and all those people are saying about normal physics, where it is there in the standard textbook in the school they teach, or in college they teach. So these things will diffuse through that. And that's the idea. Christopher, also, I think we all probably will start a virtual class. That's why I want the World University, you might say. And then he said there are certain platforms already available. So we may start with them and then collaborate with them. So we can do a virtual class, slowly introduce, and that will diffuse. So the next year, they may include in the curriculum some of the aspects we are talking, like iSpace or GERT's metric universe, or my superluminal thing, and then Emmanuel's graviton thing, and Laszlo's, ball lightning, things like that. Now, coming to Laszlo's ball lightning, recently I thought, I think I might just show in the conference, but this is the interesting thing I saw. And by the way, I'm doing also a documentary movie. So this is a project documentary movie that I plan to do, and there I can put like Christian said, 1 hour or 30 minutes of our conference. So some highlights I can put it there. This is partly my thing that I'm going to present. I may present. I may uh, do some initial rehearsal, but I have a lot of things, and then see with Christopher and all of you that whether. So this is the stagnant. So this is one aspect. I'll come to this later. But the last close thing I want to show here. It's an outward idea. It's like a puzzle. So essentially, I'm saying is that we can think of a hall in three XYZ dimensions, and this hall is an electromagnetic thing, associated electromagnetic thing. So the hint here is to use Maxwell equation and then show that this can produce ball lightning close to the surface of the Earth. So use the electromagnetic theory. So this is like a puzzle rider, like a physics rider type of thing.
Can you magnificate this? You can.
Yeah.
No, this presentation. You can go in presentation mode. And then the picture is yes. Now you are editing.
Yeah. So now 1 minute.
The font size is maybe a little bit rough of the handwriting for the presentation screen anyway, so we can have you sort that out in a PDF form before you do that. So let me say I had a look at Laszlo's paper, what he tried to prove in China when he visited the China lab. I'm not full into the details of what he exactly measured there from his paper's point of view. I read them twice. And
yeah, this is the one.
Oh, sorry.
Can you all see now?
Yeah.
Can you see now?
Yes.
Okay. So this is the idea.
I told you before that about what I did in China. I will personally, between us, without any presentation, I want to talk about.
Okay.
Do you understand? And
yes.
another thing, last week I have had a very hard days because my chief of the clothes selling was sick, and I didn't have time for a lot of things. But in this time, in this hard time, I finished ball lightning article. Late evening, tired, and it is resolved. But I will publish only in Hungarian because I want to prepare for our conference, and I didn't have time to translate better in English because the English version will be more better than Hungarian one.
Okay.
Okay.
Yeah. So you are going to translate it after you write afterwards. Okay.
You can translate it with translator, and if something you don't understand, I will explain. And I said that the English translation will be enlarged because I am now sorting the text because I don't have time to prepare how is it better.
Okay.
Example, I made the final part, the creating light botany in outside and creating light botany in lab. And this have to be described who did, the Japanese and the Russians and the Chinese perhaps they are made in outside, but this is not well prepared. And I have had three description in the Nervi where I am working. One before 3 years ago, and other two cases before 25 years ago, around, because who observed this phenomena, they can tell very well, because they did not remember how it was in that time, and I wanted to attach to the article, but I don't have time. And in case of English article, after our meeting, after our conference, I will do it. It's good because now it's important to organize our conference. How we can do it in a better condition.
That sounds good. Yeah. So I just want to update. Okay, go ahead.
And excuse me, last time was very important because now we have explanation in case of lightning caused ball lightning, and in case when it appears on the in clouds. Similar phenomena. Okay. Totally similar phenomena, and you before a few minutes you showed about the Maxwell holes.
Yeah.
That is overpass the Maxwell holes, because in case of it he didn't use he didn't have the cell, not the cell, no, the envelope of the hole, because in case of ball lightning, it's very important to have an envelope of the or outside of structure of the ball lightning, like in case of the soap bubbles.
So the Gauss theorem, about the Gauss theorem, does it compare?
Exactly.
The Gauss, Gauss, Gauss. You know, Maxwell uses, he tried to combine all of that together. The Gauss talks about the geometry, the surface and the volume aspect. But I know that I have modified Maxwell theory to include monopole. I published, in the ResearchGate, like more than 5 years ago. And then I think we can modify the Maxwell theory. We can use it as a base, but then we have to modify them to include the the surface, the geometry, what happens outside. Like it's almost like we may have to use de Sitter or anti-de Sitter space, things like that. I think so. We have to apply the de Sitter or anti-de Sitter because I would think anti-de Sitter is inside, like if like Gert's thing will be anti-de Sitter. We are all sitting inside the black hole. That will be like anti-de Sitter, I think. Now, if you are outside of that, it will be like a de Sitter. So if you are looking the ball lightning inside of the ball lightning, it will be like anti-de Sitter. When you are looking from outside to the ball lightning, it will be de Sitter space. So we have to modify Maxwell equation with de Sitter space. So that's something I can actually put it here. I should add here in the notes. Okay, so I'll say here. Oh, I have to go here. Let me see.
You can start from current slide here. Yes.
Yeah, it takes a few minutes, a minute or so. Yeah. So here you see that here. Now I didn't put your ball lightning, but if you add that, I should put your name here. But if you add that, if you put them together, we get ball lightning. Let's say we see a ball lightning here, and inside here will be anti-de Sitter. And then when you are looking from outside to here, it will be de Sitter space. So then we modify this Maxwell equation with this understanding of the de Sitter and de Sitter space. I think it will change. I mean, the main thing. What are the main things in Maxwell equation? The field, like the field strength, the magnetic field strength, electric field strength, and the curl and the divergence and all that, gradient and everything. So it talks about how that is, but how the geometry will change that. So that's the important thing. So probably you could explain why the ball lightning forms. That's something I don't know whether it's possible. Normally, science cannot explain why. The science can explain how, it cannot explain why. That's the main problem with science. But I think we can probably get around and see some aspects of the why, because what is happening is that you say that how it affects the gravity. So again, the relativistic aspect, the Einstein's thing come into picture, whether the gravity is a primordial thing or a secondary thing. We believe that it's secondary. The primordial thing may be magnetic thing. So if it is a magnetic thing, how this so initially what happens is ball lightning from an anti-de Sitter space. I'm thinking aloud. So very general thing I'm talking about. Initially the ball lightning, it's like anti-de Sitter space. It's in the the electromagnetic waves and the anti-de Sitter space. But then something, the gravity or something, that brings it together and makes into a de Sitter space. So then you can see what we can see that. So you see that if it is anti-de Sitter space, we are inside that, we cannot see it. But the de Sitter space become localized and they become observable, and we can observe that ball lightning. So it is how it comes together. I think that's the important part, because and it affects the gravity's interaction with gravity. So the electromagnetic gravity is the main thing there. So how this electromagnetic. So when you do the experiment, like you said, you conducted an experiment last row. You said, but you couldn't get that answer. It didn't give you the answer, and that
Excuse
because
me.
then you have to. Yeah.
Excuse me. In case of China, I made only a gravitational experiment. Nothing else. It's very simple gravitational experiment I made, and I have showed on the 3 videos on my YouTube channel. that it was a prediction, and this Chinese experience it's give positive results, and it was did in every day in 14 days. I repeated the experiment, and and one thing is very important with this experiment. One phenomenon, not phenomenon, one thing of the ball lightning example with this experiment can be give response why the ball lightning enter going inside the room in the open windows or open doors. It is a simple answer that they go inside because the gravity is bigger inside the room like in outside, and my experiments with my experiments can be say that it's good. And one thing I would like to ask for you and for you, Christian, please send me question about to test my my vision about the ball lightning. Can I give response to your questions or not? About the phenomenon of about the different causing of the ball lightning, example, stopping in a place or everything. If you have a question, I would like to ask me and to test more, because I tested minimum 9 questions of a Russian ball lightning expert. I don't can say his name, but to all 9 questions, I have opportunity to give a positive response. And I would like to ask, exists in literature that the ball lighting go inside to the house on the windows, close the windows? That is not true. It cannot go inside. Or in case of the wall of the house, that it also is not real, because the wall and the windows has stopping is a resistance to the electromagnetic phenomena, because the ball lightning is an electromagnetic phenomena, and in this case cannot go if it is a resistance in its way. It cannot go inside in your house without open door or without open window. Okay.
I completely agree, Laszlo, so that any electric phenomena will interact with matter, and wall and glass is, except for light, which is uncharged, at least nominally uncharged, that we don't know yet. It could be charged, positive, negative compensating thing. There are theories there who think light transmission is not electrically neutral. But aside of that, it's completely clear that any charge cannot bypass atomic structures of any other charge without influence. That is just a myth. Yeah? So that may be a nice novel writing thing, but I don't believe any of the reports in historic documents or current contemporary ones where I've seen a ball lightning and it moved through my glass window. So you every now and then read about these things, but I agree that that is not the case. On the other hand, you have to see what I already answered you in ResearchGate. On the day when you published that paper, I immediately wrote you not that too long, but what my spine probably told me about the facts of your writings, and I gave you feedback, but you have only answered me briefly so far. I'm not sure if I'm in the expertise domain of that to give better feedback, but where I can give you feedback, Laszlo, is your weighting experiments, which you did in where you claim these are simple, and your understatement is sheer amazing. They are not simple, Laszlo. This is on ingeniously clever level. This is a very, very clever experiment. And the more simple it is, the more clever it is, because everybody could do that for decades, if not centuries, in any normal lab, but seemingly no one did. And you were the one going into a lab and did that weighting experiment. I don't want to go into detail. Everybody here in the video shall please read that very brief paper. It's about only 5 to 6 pages of Laszlo on ResearchGate on his home, what he did there, and it is stunning. It is just outright stunning because it's so simple. And in a sense, what I can summarize is he takes a weighting device, puts it on floor level of a bigger lab, and puts a horizontal bar to weight that, including that, and then puts the same bar with the weight in vertical form on the weight. And as the atoms of the bar in the vertical form should weight the same than in the horizontal bar in traditional theories, they are not at all doing that with respect to the dependency that some of the atoms of the bar, and depending on how high the bar is it's not clear how big the height difference is, but current atomic clocks are able to measure into the picometers range with weight differences of gravity. And the much more clever thing is to then move the weight, the apparatus which measures the weight on the higher level, and then repeat the experiment on the higher level horizontally. And I cannot go into detail. You have to read it yourself. But this is just outright intriguing how simple that is. And to claim that there should be a weight difference from your point of view and no weight difference from a classical rather relativity or even Newtonian theory point of view is easy to see from my point of view, even as a novice in this area. And that's why I think it's so important to make these things public. If it's so simple, then people should pick it up and repeat these measurements in labs with the highest possible precision they can afford with their lab equipment. And I think they will be also confirming what you found, that you, if I understood you right, Laszlo, you had positive confirmation of that there is a difference if he has a horizontal or vertical on the weight. There's a difference if the weight is on the floor level or in the top level of that measurement apparatus. And from a classical Newtonian theory, that would be a zero result. And as that result of you was what I understood, not a zero result, that is spectacular enough already, with the measurement precision being able to make in that lab, of course. You need a high precision weighting device, of course, to do that. So then your average kitchen weight will not handle that, but I have no details, unfortunately, yet about that. It wasn't written in the paper. Yeah, this is the picture I wanted. Yes, exactly. This is ingeniously clever, as simple as it is. Yeah. So this is.
No, these experiments I tested in China.
Yeah.
With simple measurements.
Maybe you
and I don't know. I don't know if we have a chance. I don't know, because I didn't tested what kind of buildings are in Budapest. I don't know if we have opportunity to do the experiment there. Now I don't know. Example, I have looked on Christopher town. The example, Christopher can do the experiment, can repeat it.
Laszlo, when that is peer reviewed, I can offer to bring that to Harald to ask his buddies in Garching to say, hey, somewhere in Garching.
I will bring totally the tools what I did the experiment. Okay.
This is important
because nothing I changed it.
How to repeat the experiment in detail. There's the full details are missing, but I can understand the logic behind the experiment fully.
It's a simpler weight experiment.
It is, but as you say, if it is not simple enough that is instantly grabbable for the average scientist, so otherwise they had been doing it before you, and it was necessary for you doing it and showing them that something in their thinking is short-sighted. Otherwise, that wouldn't work.
We can describe this last law. What I understand from this picture is that you have something here, you are putting some vertical thing here, and then here it's horizontal, right? The B.
No, this is the
horizontal?
pink one on top of the blue one on the left side. This is only one of two images. On the second image, the blue bar is horizontally weighted on B, and independently P is weighted with and without S in the different construction, and they should sum up to the exact same weight. But they don't, because the P is higher in picture A dot than in picture B dot. And that is already enough to make a difference. And
P is up here, yeah. P is up here.
Yeah.
And here it's lower. Yeah.
But the text
the text explains it very well.
It's explained in I have made 3 videos about this text of the ResearchGate. I have 3 videos too, and with English text. And in this case, you can understand better, like in case of the in the description.
Okay, so let's
the experiment. Okay, the experiment is simpler. It's example like if I was in sky or on the ground. That is what's important, and I tested everything in this case, and the experiment has very high value in case of example in case of the prospection methods or everything, because the experiment was tested in case of in the plane when I was before to arrive in Budapest. I made measurements on the plane, then 10 kilometers above the station airport, and when the plane arrived in airport, I made again the experiment. Because I know one thing, that we cannot get results from the academic staffs. They do not give us their results. We have to test with what we have. It is similar. What?
Let me explain what I understood from the text here. We create a long rod, relative uniform density whose weight is the vertical or dissembled, placed horizontally on the scale. So what you're doing is that is this the scale, the Merlin? Is this the weighing machine? Is it like a balance?
Immediately, I will try to find.
No, is this a measuring? Is this a measuring equipment?
Machine, yeah.
Nothing simply. It's nothing simply. You in similar place. You may if you have a road, example 10 kilometer long, and one part on the near the ground, you measure its weight, and after that you inverse the rod and put on the measure again. You will get other weight.
But
you have similar rod, and you will get other rate. And in this case,
you subtracted the weight of the rod, isn't it?
So let me read this here. So placed horizontally. Okay, the rod is placed on the balance W.
And it is very important. You in this case is violated.
Yes. Okay. Yeah.
It's violated. Example, Newtonian gravity model. The example Einsteinian general relativity is good, but in case of Newton gravity doesn't work.
Okay, so let me ask you, Leslo, how do you support this one? If it's a long one, something has to support this, right? It will not stand, it will fall down, right? How do you support? Use any support system to keep that vertical?
It's only it's imaginary experiment.
It's not a real experiment.
It's only imaginary. That is why I made three form of this experiment. And in case on China, I made the fourth type. That wasn't described this experiment in China, but it has similar effect, similar result. I am sure that if we made this experiment, the experiment will give positive results. I am sure.
Yeah. The question is, you need a support system. Something has to support this one to keep it vertical.
You have right, but we don't need support if we have example one tool which with the same measurement tool will go above the measurement point with 10 kilometers and will repeat the experiment. And in this case, we don't need nothing to support it. And example, we have 1 kilogram, and in this case, example in Newtonian formula is described with how we know his formula, but we can explain with other terms this story. I have it, but I need to think more about it.
Just pick up a pen, okay? I need something I have to hold here or something. Otherwise, the pen is going to drop down, So let's say this is the pen.
And example, excuse me, Ryan. In case of the drilling tools at the oil company, because I worked 8 years at the oil exploration, it can be do with them this experiment. Example, when it's drilled inside in the ground 1 kilometer or 3 kilometers of hole, it can be done. It can be done there. This experiment too.
Because this is a hole, so this is inside a hole.
Exactly. And we don't need example. I think, but in case of hole, the problem is the hole diameter is very, very little, and perhaps the experiment will be affected by the hole, the wall of the hole.
Yeah. That's what
electrically will affect the experiment. In this case, because
static electricity you will have.
Exactly.
So this supports, the hole will support this long rod. That seems reasonable. And then you have something, you are actually digging something, so you keep your balance here. And then
what kind of balance? With a spring or with another weight?
Normal, what you call
No, there are two kinds of balances.
Yeah.
Only one. We have to use only one balance.
Yes,
example, we can use more balance, but
if you have a balance using a spring a spring balance will get another result than balance with Balkenwaage. I don't know in English.
No, there are Gerd, there are two types, and you are correct. There's one spring balance, and also there is a platform balance. We use platform balance where
platform.
Platform. So
Mm-hmm.
the spring balance, I feel your idea is good because you should check with both. You change the platform, use a platform balance, and then use a spring balance and see whether you see any difference. That's a good point. Yeah. Two types of balance you can use. Here it could be spring here, like that, spring here, spring balance, or it could be platform, like we use for example, I have one where I use for weighing, myself. You find your own weight, you stand on there, or you can use for, if you want to use for, that's almost like spring balance. If you want to weigh the luggage before you come, you have to have within 25, 50 kilograms or something like that. So you weigh that. They have new things of which works like a spring balance, but it is electronic. The other one is you put it on a flat space, and that's more like a like a platform balance where it's magnified. It's small things magnified. I mean, we know the principle platform balance. Slightly different from spring balance. Spring balance is more simple harmonic motion. Platform balance is a lever action type of thing.
From a practical point of
way.
view, these platform balances are easy to be made because they are difference weight balances by, let's say, 4 piezo sensors in the feet, and you're standing in an average on the top of the middle of the sensor plate. And I have still one with a single sensor plate. This is a very interesting construction. And that was when the prototype of these weights was very new. I have a glass plate we're standing on, and basically the glass plate is super glued to the sensor supporting structure, and the piezo element is only fractions of a millimeter bent by your weight, and it can still weight you to the I think hundredths of a gram or something, like really, really, really precise. And but the technology for balances which are multi-point weighted are much more precise and much more easy to handle. Think of, you would have not one rod but 4 rods, and the 4 rod would connect at the top and would stand on the bottom on 4 individual calibrated weights. Then you could put these 4 individual calibrated plates together and electronically do what a standard bathroom weight would do with the 4-point sensors. And that is technically easy to do because you do not need much calibration from a software point of view. That is actually a trivial to implement task. And hence, you also answers your stability problem. You have no stability problem because you take just 4 rods and weight each of the 4 rods, cleaning them carefully, but because I don't know on what precision area it is. This is one of my questions to Laszlo, on what kind of precision area we are talking about. So when you weight something with a ton to the milligram, this is different than if you weight something with a kilogram to 10 gram or something. So you need a difference resolution, which I could not find in your paper yet, what kind of mass you need to prove the effect until it becomes...
We don't know. We don't need high mass. As I told, I will bring with me. It's around 1 kilogram.
Just on average.
Only 1 kilogram I need to bring with me to the Budapest.
So 1 kilogram in vertical form and 1 kilogram in horizontal form, and you already see the difference.
Only 1 kilogram I need in this case.
And the precision of the weighting device.
And exists another tool. This is because I have used 2 type of measurements before when my balance was not so poor measuring. In this case, I have used bigger body for measurements, and every time I have used the insulator type of object for measurements.
and give me a ratio weight of the kilogram. So when you say you need just a kilogram, what is the resolution of your measuring device? Is it
it was
what is it?
It was nulla gram.
So
it was not example. The balance was used in case of selling of gold, like a balance which is used.
But so in the we're not talking about nanogram or picogram. We're talking about
no. In case of nanogram and picogram, we can get better resolution in a small distance. Example, when I have used it in my environment, in what balance you told, it can be used in smaller smaller distance. When you come in Budapest, please ask me, and we will discuss about it. And if you have I don't have opportunity to do this experiment, but if you have such a balance, you can test it. Do you understand, Christian?
Yeah. Okay, perfect.
Okay.
Yeah. This balance here you are shifting.
And another thing I would like to ask you. Before 10 days, one family come in the shop and tell about the ball lightning happened before 25 years ago. They explain it that the ball lightning went in the house in the open door and disappeared on the switcher of the bedroom, and after it the bedroom the lightning the light of the bedroom all conductor of the house was destroyed, but in the bedroom immediately
Here,
bedroom pair lightning light pair, it's continuous have light. Do you understand? Immediately I will try to find the word.
you see ball lightning inside, you say?
Not paired immediately. Not you. Okay. Light bulb is continuing, but 3 hours was like he without switch on, we switch on the light in the bathroom, but it was light there. And I can explain this situation, but yesterday with my son we have a discussion, and he told me that I am crazy. But I think that it can be explained because the light bulb light worked similar like in case of formation of the ball lightning.
If you have a proper,
and I would like to ask that electrical
light up a bulb from a 10 meters distance, so this is not a problem. The question is rather than can it really can a ball lightning be sustainable from an energy point of view for 3 to 4 hours, generating the necessary field in 10 meters distance to light up a 220 volt light bulb. Because normally you would need a coil on the light bulb. When you have a Tesla coil, you have a coil below your 220 volt thing. Tesla presented that on stage.
Tantalum or whatever, yeah.
Presenting his ideas. There are good documentations about what he did and what is possible. But nevertheless, a Tesla coil is a massive thing with a literally lightning generating sparks environment, so that you have a high power electric field in the dozens of meters distance, can even be dangerous to your health, depending on your health conditions. And I don't see why a phenomenon which is so scary, rare, that you can barely visit it ever in your life, should sustain for 3 hours inside a room. So that is difficult to understand what the lightning ball loved so in this room to stay persistent. Yeah?
One explanation is that the conductor of the light in the house was destroyed, and in this case was created an insulator, and the energy of the ball lightning remained in the light bulb, and hadn't chance to escape from it.
Yeah, but I think copper wires is one thing, and creating a standing wave in a coil with a resonance field is another thing. So with AC, this is comparatively easy to do. But with so what is lightning anyway? Is it AC? Is it DC? Is it just a combination of both? We don't really know. So but if it is a changing field, this is difficult to judge in case of a lightning. Normally, we assume that is a persistent DC voltage which comes from the cloud to the ground until it discharges. And the discharge goes from the ground with a pre-lightning from the ground to the cloud until the main lightning comes down from the cloud to the ground. And all these kind of physical effects which are proven in laboratory and other experiments with high-speed photography. So we know that for sure, but that doesn't mean you understand it.
Yeah. So one of the things is works like a capacitor. You know, if you have a capacitor and you discharge the capacitor, then suddenly you have the charge coming out, right? So capacitor breakdown, like a capacitor breakdown. So it acts like the clouds act like capacitor, and then suddenly you have the capacitor breakdown. So that releases the electromagnetic waves, which comes as lightning. So the other aspect is, I think, the ball lightning all those, it depends on the confinement. You know, so it's environment matters. Like I said, the silicon oil, for example, it could confine that, like magnetic plasma, like in fusion experiment, you have to confine that, right? Confine that plasma inside something. So you need something to confine that. I think ball lightning needs something like that. Silicon oil, the problem is that because you apply high voltage, high spark, high voltage, whether it can degrade that silicon oil. That's one thing I was concerned about. But silicon oil I used the experiment. It's very nice. It keeps everything intact. Like to use for example slip steps and things for materials. But it's a nice environment which keeps everything without oxidation and all those things. So that's one thing you need a ball lightning, because you have that it gets oxidized very fast. So it goes away. It removes it. It doesn't last. But if you have something that confines, like something that does not do oxidation, uh, so it will be like silicon oil, some other things that can confine it, but at the same time, it doesn't cause anything. So you can use a magnetic type of confinement. I don't know, it's possible, something like that. But the magnetic problem is it could have interaction. So you need a confinement which does not interact with the electromagnetic aspect of the ball, but at the same time it can confine it. At the same time it doesn't break down like many other organic materials break down at certain voltage. They have the breakdown voltage. You can actually figure out. I think there should be some table where it can break down. So you have to have something. It could be a vacuum, but vacuum is hard. Vacuum is probably the best, I guess. But like in our ball, like our tube, our bathroom light or anything. It has some kind of a vacuum, and there may be some helium inside, a little bit of helium inside, I think, or some gases. That's it. And then you have these wires, either platinum or tantalum or some other material, and then because of the high resistance between them, it converts into heat, right? I mean, you have very high concentration of the electric charge, and that it just breaks that, comes out as the light because of the heat that creates, because the high resistance, it creates very high level of heat, so the temperature goes up. That's why you see the temperature going up, and it has to stand up to temperature. So tantalum or some other material can stand up the temperature. It doesn't break down, and it doesn't get oxidized because it's essentially a vacuum or partially filled with helium or something. Doesn't inert gas. So something like that, you have to create. Maybe you can use helium to confine that. In some inert gas may be a good thing, and you have confined chamber, and you have helium inside, and inside that you can do very similar to bulb, glass bulb, very similar thing. But only difference is that you are applying very high voltage to create a confined field like plasma. So almost like plasma, I would think. So you have to create something like that and use, if necessary, magnetic thing, magnetic field to augment that, to amplify that. So something like that. But essentially, you can work like lightning, like a capacitor. So you make like a capacitor. I mean, I'm saying that it's not a solid capacitor. It is a fluid capacitor where you have the helium. Inside that, you create like very similar to cloud, positive and negative charges, and they're separated by a certain distance. And then you discharge, and then discharge occurs between them, and that creates the spark. But it's contained. Because it's contained, it will start creating your ball lightning. I think that's a possibility. You can try it. Something like that. An idea. I'm saying, thinking aloud, an idea
Yes, as
that
far as
could
I know,
that
Raja,
could,
no experiment on the world today has ever created reproducible ball lightnings in a laboratory, not that I have ever heard of.
In laboratory, in case I have seen work of the Japanese. I can tell the name now because I don't remember his name. But but this Japanese guy made really ball lightning, because the characters description has similar with the theoretical concept what I have written down intuitionally. Exactly similar description has the Japanese.
Yeah, I will not exclude that someone managed to do that, but I have not heard of so far. This is like with mainstream science, is not accepting ball lightning in laboratories, which doesn't mean it doesn't work. So it just means it is not accepted science outside of special labs, which are not known enough yet. So it would
the ball lightning. The ball lightning are very differently, because the ball lightning which appear in the clouds is not the same like the ball lightning which appear on the ground caused by lightning. In case of the ball lightning in the clouds, they have to be close to the plasma type ball lightning. But in case of the ball lightning which is upper on the ground, are ball lightning created from electric charge from electron fluid. Something electron fluid. I have the correct term for it. They are different, but the process is similar. The process of creation is similar.
So plasma So the near the ground, it's not plasma.
In case of ground, I think it is not. I have to say it. I think it is not plasma. Only a very small part of the ball lighting in the ground has a very small particle of the charged air. But in case of the ball lighting on the air, it has more charged air and a little part of the electric charge electron fluid not I don't know how to say to this material.
So these, sorry, I will finish now and say goodbye. Yes.
Oh, thank you.
Rajan, I have to do the same. I see it is 7, so as I'm already over a quarter hour of the budget where I've planned. I thank you for your time, and was happy to organize that. And you will hear from me for the hotel stuff for the conference Text 2025 Budapest in the Monday or Tuesday region once the hotel has confirmed. And when I have sent the PDF to them, I sent you a CC over the text organizers group so that you are aware. But other than that, it will be just what I have discussed before the recording was started. And you have all agreed that it's a fine way to go. And then so we nail it. And let's see that we have another point, Formula 1 locked away, that we can focus on the details more than the next time. Thank you.
So you can give updates on that on the WhatsApp, but
I make WhatsApp updates for all of you. But as said, so it's just a formal process now.
So basically, booking and all that. Yeah, appreciate.
I'm doing that latest Sunday, and then we have results. Hopefully, latest. With the important thing is not that I do the booking. The important thing is I get the confirmation from the hotel. So.
Yeah. So, like I'm CEO, you're CFO, Christopher will be CIO, things like that, and they'll be directors, something like that in the non-profit organization. Okay, that sounds good. So I think everything is working out. I think we'll get a better idea in the week or two of all the things. I think, we'll put everything together and then.
So possibly you're planning to do another text invitation next Saturday regularly, so we should already have results there from my opinion point of view.
Yeah.
We try to, after sending the mail on daytime, to call the Mr. or Mrs. Bergman, I think it's Mrs. Bergman, Nicolette Bergman, and see what time she takes to give an answer formally. If I'm able to catch her on the phone. I wasn't able to get her on the phone on the last week. So probably either she is busy or difficult to reach. But I will try when the paper is formally that I'm confident that we have a quick confirmation. If something needs to be changed, then I will call you on WhatsApp voice or something like that to discuss that. Yes, either if there's a cost raise or whatever planning change, then we need to discuss again. But there's still enough time for that, and let's hope that is the final round, and then we have that sorted out. And thank you, and have a nice weekend.
Okay, thank you, Christian.
Yeah,
we'll see you next week. Have a nice week. Yeah. Thank you. So, So, Laszlo, I just want to, you are going, just want to update this one. I don't know whether if you want to stay, otherwise you can go, but I am just updating everybody what we did today, a brief thing, very brief thing. If you want to stay and you can look at, otherwise, if you want to go, you can go, but again, thank you very much. We will try to, so let me go over this. Again, all of you, this is our about page, which has not changed much. I think we discussed last week. The speakers, again, all the bios are here, mine here, and then Christopher, Christian, Gord, and Laszlo, and Emmanuel also has updated some things, and Christopher is continuously updating this. So thanks, Christopher, and also Christian is getting on to this thing. So this is our uh, committees. That is the same, but the schedule Christopher has updated. So here it starts, and then you have the abstract here that tells what we're going to talk about, especially iSpace. And then Gerd is going to talk about his thing. And good thing I like is that he's saying that we are probably inside a black hole. Uh, his research has shown that it's compatible with iSpace. And then Laszlo is already sent the abstract, so Christopher should be updating this pretty soon. Then I have my abstract where I talk about superlunar condensate. The work with initially started with Emmanuel. Now I am continuing with the time aspect, the rank 6 time, vector, and the scalar times, and then how that affects, what we measure in terms of measurement of CMBR or gravitational waves. I think there's a micro level of these aspects. So I think we can use that to actually figure out how exactly gravity and the time are coupling together to create the geodesic effect. That's critical for our own life. That's how our life came to being. And then I believe one of the things that I might touch upon is the pattern symmetry, apart from this. And the pattern symmetry says that they're local and global. There's a local, it's essentially a prime factorization process. And then, so the locally, with that process, it will try to create a symmetry, but then it will upset the global. So it has to switch back and forth. That should become dynamic. And that's how we form that. So it's a simple way. There are more things to it. Then Christopher is going to talk about his atmospheric cosmology, uh, and that 24 cell, his tangent plane, how you can you're going to talk about even dark energy, how all the galactic objects are coming into picture, how we can analyze that in a much better way. And then after that, Emmanuel is going to talk about the graviton experiment he is trying to create to for superlunar aspects, the fast run speed of light aspect. Then we have the dinner. After that, we may extend this one. So 3:45, we may go up to 4:30, and then we will have vote of thanks, things like that, another 10 to 15 minutes. And then later in the evening, around 8 o'clock, 8 to 10, we'll have the dinner, social events, and things like that. So that then we'll wrap up the conference on Saturday. We'll have some sightseeing, and then after that, in the night, we'll closing ceremony. We'll talk about what is going to happen in the future, like the future conferences, maybe after 6 months or probably like a year after that, probably New Zealand, place like that. That's one place that's possible. So we continue that, and there will be larger things. Here, there's only one day of conference, as you see, but in the future events, we will have more number of days and also multiple places where you have session chairman. So we may collaborate with some other conference people to do that also. And Christian is working out all the economic, the financial aspects, and I think is coming up. People staying there, and then conference days, what's happening. So we'll have a better idea because he's going to book this book ticket, book our stay there, and also the conference aspect. He's going to book, reserve the rooms, everything. So we'll get a better picture next week of that or following week. Then, so that is essentially the conference day, official conference. Then Saturday is a winding up. We'll have city tours and also local museums or science places or the university that we have to figure out, and other places nearby. There's observatory or something. Then Sunday it starts post conference aspect. Again, we will visit places, could be just outside of Hungary, and there's a plan to go all the way up to CERN. I have to talk to that. Then I'll fly out of Switzerland instead of Budapest. So these things are there, and whoever want to join, they can join, and we can go there. I have sent uh, email to CERN, and they said that they will reply in a few days, but they said it'll take time because uh, they have a lot of demand. So they said they will demand. So somebody look at it maybe after a week or two. I'll get information about CERN, whether how we go about doing that. Then, if you want to send some article, you can send to the email, which goes to uh, which goes to Christopher, Christopher's email, and then you can put all the things, details if you want, some subject. So, oh, okay, I don't know. All right, so let's see. All right, so
And
that's essentially what the conference is about. And I just want to give a heads up about. Oh, did I? Oh, I didn't present it. Sorry, I didn't. I thought it was presented. Uh, Let me go back again. Sorry. So I was explaining. I thought this was on again. Actually, this was not on. Okay. So let me go over that. What I talked about. About the speakers. So now you can see it. The bios are here in the conference website. You see the conference website here. The signs on the web, text.2025. Then we have the committee, then schedule. I went through the schedule, and the abstracts are there, iSpace, and then Hubble tension, and also the fact that we are inside the black hole and iSpace is, corroborating with that, compatible to that. Laszlo has sent the abstract. It should appear here anytime. Then I have my abstract here, superluminal things, and also the how the gravity and the time interacts to create geodesics. Then Christopher has his measurements, galactic distance using tangential plane and arrangement of the galaxies, and then analysis of that using hyperspace. Then Emmanuel has his superluminal graviton, how that vacuum, and then faster and speed of light. Then like I said, the dinner that night, and then sightseeing next day, and then closing ceremony. So we may extend, like I said, we may extend to 4:30, and then another 15 minutes vote of thanks. Then we have the dinner on the conference day. The next day, Saturday, the sightseeing, local places that with Laszlo and other people will be trying to arrange that, seeing science museum and things like that, or other places. Then closing ceremony, we'll talk about the future things. Uh, this documentary movie I'm creating, but there'll be virtual classes, world universities. They'll be hopefully after a year or so, in a year's time, we'll have probably next conference, uh, New Zealand, probably New Zealand, possible venue. And then we'll have probably collaboration with other people. So you can have multi-day with multi sessions each day conference. So a large number of people can present, uh, along with the collaboration with some other conference platforms. So that's what we are trying to see. And post conference is where, like I said, sightseeing just outside Hungary, even observatory, and all the way to CERN if possible. Those who want to join, they can join. But the main thing is the conference day is where all of us come together, all the 20 people. The rest of the day are a little flexible depending on each person, how they want to do it. So that's essentially, uh, in a gist manner, that's how the conference is going to proceed. Uh, and then we plan to have next week a better understanding of the main thing is the reservation. So we need the booking that Christine is doing. Once that is done, a lot of things are settled, and then all you have to worry about is our going around places and things like that. And then so thank Laszlo to be the local. And then we talked about a publicity aspect, the plus aspect, which I think Christian and Laszlo are going to look into, because we need to spread our news so that people know what we are doing and they get more interested, and we get more people to join us. Interesting. And then Laszlo already talked interesting experiment. He may give some more demonstration type thing at the conference. So that way we have a lot of things going on right now. And then so that's essentially that will say. And then one other aspect is, let me make sure that, okay. So one other aspect is, one other aspect that connects with that is that we are trying to also see whether the hotel later on, whether they can have a pickup from the airport or whatever you're coming, depending on the conveyance. That's a different aspect. That should not be a big problem, I would think. There are many ways you can arrive at their flowers. But the day of the conference, we still have to figure out how many people are coming and how much room is there, depending on what is booked. And that's the important point. So there will be people locally who can come in. The other people, we encourage them to register as soon as possible. We have next week, end of this month will be okay, because there are the speakers. I think the abstract is there, so I think we are kind of almost 50% ready to present, and then we have to make our choice. The only other aspect, if Laszlo want to look at that, I have a recent publication uh, of this one, which I'm going to give partly. Let me see. Okay, it's called a particle charge. So this is a new one. Yeah. So this I'm going to present, which shows about the graviton thing. That's all I'm saying is that it shows about the graviton, how the graviton spin spectroscopy. So E over M, that's an old measurement, right? Particle with Rutherford and all. Then the spin number, but that's a new one, quantum. So how you measure that using and then using thermal version Bohr magneton. So we can use this for experiment to find out whether, hopefully, it may be theoretically possible graviton is present or not. So that's a big question. All of us have some common theme. Finally, we come to the idea of superluminal thing, and graviton is our main thing that everybody is kind of the common for everybody, the graviton aspect, the spin 2 particle.
Brian, excuse me.
Yes.
In case of our dimension, I think we don't have the space is not made from graviton. It can be concepted with other form on the base of the a priori entity. If we think with this concept of metaphysical concept, that is particular on the scale of the Planck, it will be also an a priori entity with similar aspect, but its nucleus will be only null. We can say null dimension, and its space phase will be bigger, and in this case we can get a continuum space, continuum media in
Uh,
our dimension. Do you
okay.
understand?
Yeah. So, yeah, I can see the thing is I space that Christian is talking, and the quantum aspect is at the lower scale. So, in our scale, like in mesoscopic level, we don't see that because it got blotched over. You know, we cannot we don't have resolution unless we
And
go into the small scale, right?
and
We
in
cannot
this case,
resolve.
and in this case, the term of the graviton is not so good. We have to find another term.
Yeah.
The graviton is not
So
good. It is only in case of the it's in case, like in case of atomic
yes,
nucleus is connected to the photon of the electron. In such a case, we can catch the graviton.
yes,
And
yes,
as you told that that is similar some micro black hole, like
yes,
in case of your term.
yes. Yeah, it's a micro black hole. So there are only two entities mainly in my thing that comes from the superluminous thing. One is the 0 point field, which appears eventually as a cosmic as a wave. That's part of the wave, cosmic wave, radiation. The other one is the micro black hole, which comes as gravitational wave. So these are the only two entities mainly. One is like light-like, uh, or photon-like or light-like, which is cosmic microwave background, CMBR. The other one is the gravitation wave, which is like sound-like or phonon-like thing. So these are the only two main things, and they come out and then create space. So then you have fermions, you have bosons, and and then we think that fermions and bosons probably are formed from gravitons. So gravitons dissociate in our thing; they don't exist in the real system. Only in superlunar space it exists. In our system, which is sublunar, the graviton cannot exist. So which means that it splits up into fermions and bosons. So you have electrons, and then you have photons, you have phonons, or the sound vibrations. So they form the sound vibration. So they split up, into sound vibration and the light, longitudinal wave type thing, light, which can travel almost infinite distance. We think that, see, the other aspect we have to look into is we think that the light is not affected. Like we see light years away, that information we get after many millions of years, we get information. We think that information is still pure. There's no distortion of that thing. No, the light can come right through. And but the question is whether that's true or not, because that information is very important to us. That's how we know what happened, like a black hole merger, or the gravitation waves gives that information. But what happens, light years away? What is happening in the star? In a star, a star is forming, and we get that information after a long time, and we say that okay, this has occurred millions of years ago. So we go back and then recalculate that. So these are the things that's inside that star. But the question is that light pure? Is that distorted somehow or corrupted on the way here? So are we getting the right information? That's always a question. Always I had that in mind. Right now we assume that yes, the astronomy, whatever the James Webb, or any other type of Hubble space, all that information is because the light does not deteriorate. So it can travel long distance and come to us and give us information. The same way gravitation waves, if there's something is happening with the particles or with the mass interacting, then that creates the gravitation wave and we get that information. These are the two main forms of information we have of what's happening up there. Now, you are thinking, Lastro thinking much more local in the sense that it's more in the earth, what's happening. the lightning that's happening in the clouds versus the ball lightning close to Earth. So I think you said that it's not plasma, but it could be a capacitor discharge. It's quite possible that close to the Earth you have like a capacitor forming because negative and positive they form capacitor, and then because of the high intensity they discharge because it depends on the insulator between. And we know about the very high voltage you apply, the capacitor will break down, so it will discharge. So that's a quite possible. That's something you can look into because you have these aspects and you see whether it's a capacitor discharge. We can calculate that. We can calculate the electronic thing, the RC oscillator, the oscillator theory, where it says resistance and capacitor, and it gives the time of discharge and everything. It's a nice calculation, right? Electronic physics, the circuit physics. In circuits, our microchips are nothing but the resistance and capacitor, right? RC circuit, resistance, capacitor, they put them together, and the capacitor gives that voltage like a battery. Battery is like a capacitor. So the battery breaks down. That's equivalent to a capacitor breakdown. So if you battery very high voltage apply, the battery breaks down and it can create this high level of discharge, and that could be the formation of ball lightning. But you need a very high voltage. So you have to figure out, depending on the medium, what medium it is resting on. Is it air? Is it vacuum? Or is it some liquid? Some fluid. But main thing is confinement is important because if it's not confined, it's going to spread out immediately. As soon as it discharges, it just spreads out. So you cannot see it. So it has to be confined so that can create that ball lightning. So these are the constraints or conditions that could help to figure out the ball lightning. And you can probably create, if you put the right condition, you can actually create yourself ball lightning above the Earth and show that, yeah, it's right there. But you have to confine them, you have to create the right conditions, I think. Last law. So
excuse me, I have looked on the purchase of the capacitor and verified that that is your approach is good, is similar with my approach to the ball lightning phenomenon and the exists connection.
Okay, great. So,
I think what I have to finish rapid the article because we have to do something to give more time for our meeting in Budapest. Yes. And I would like to ask you that what we can do with in case of the Hunren seismic. We will try again or not. Okay. I thought about it that I will give you the name of the director, and you will write an English letter and send me in email, and I will send immediate. I tell you the letter name.
So you are sending the email address and the phone.
No. I can't send you the email address, but I want to use a better. I want to send to him registered letter on the post. That is it's a better form. In this case, he have to respond to our letter. What do you think?
Yes. What is it called?
It is a tool of press of the director. I don't know if it's good or not. You decide if we use this style of I give you the email address and you you send a simple letter. I don't know what is better. If I send I am going to send a registered letter. In this time, he had to respond to us. But you
By
decide
mail,
what we did.
by mail, by regular mail.
By email. Okay.
By regular mail, but it's difficult. I think email is better.
Okay.
I mean,
Okay. I will send you to today evening the email address of the director. Okay.
yeah, okay. So hopefully they usually respond. Most of them respond, but we'll see. I will copy you. I'll copy you also in the email. So you will also see that when I send the email.
If
So
you send a letter, in this case, we don't send a registered letter. And I don't know if in case of the Hungarian Academy, can we use a registered letter or not?
uh, only locally. I cannot from US. US. It's difficult to send from America. The USA. It's difficult to send because it costs a lot of money to send registered mail.
This is not so expensive. Only €2 or three
Not for you.
US dollar. It's not so expensive.
No. It will be a lot more. It is not too. Registered is at least $20 or $30, but I don't know what they will. We'll see. I mean, if they respond, if they don't
Because
respond to email, we'll.
the problem is that if we don't use registered letter after it, the officials they will respond to us why they didn't respond to us. They will say that they didn't get our letter. Okay.
I can use like priority mail, like FedEx or something like that, or USPS. We can use that, and that will cost like $20 or $30 to send that. I don't know how much it is. You have to send me the address. I can find out in the post office. It'll be like $20 or $30. And you can send a registered letter to them and see whether they respond. But
Okay.
yeah, but I would think we will first try. You send me the email. We'll try. If you don't get within a week or something, then I can send this one. Then we can try this one. Yeah, the seismology. Yeah, only one person from the science thing responded, and that said, I think we went over it last week or before that. Letter from the science person. I think I have it. Let me check. And that person has sent me information. Let me see here. Some time ago,
Okay.
it was it was like when it was statement. Let me check. There's so many emails that it takes a while to figure out where it is. Okay. That's unique expertise. And to see where I got information from somebody. I don't know whether we discussed that. Yeah, let me. Ask okay, permission to visit. It may be here, I'm not sure. Oh, this is another one. 225. Let's see. Yeah, it was some time ago. Uh, I think it was before this. I think uh, okay, dark matters. I think somewhere. I don't know. God, wow, where did it go? Let me check. Oh, this is one thing I got. Yeah, this is one thing I got concerned. So let me pull up that. I think that was a CERN. Yeah, let me go here. So this is a CERN I sent. Remember, we sent a CERN. So my message, I'm researcher, and we sent this one. They sent a message that oh, this is in French, I think, but this is English. Thank you for contacting. Large number of messages we receive, we will reply as soon as possible. We thank you for your patience. Like to remind you that group bookings can be made using online. If your group comprises more than 48, please indicate the additional information field on the booking form. So this is a let in this is a reply I got from the CERN. Hopefully they will reply as soon as possible. So hopefully they'll come to us. So this is a CERN one. Uh, atomic thing also we got, right? You said we got atomic. I think we went over this. I think atomic. Uh, yeah, you may let me check the atomic. See what is this? The atomic. Let's see. Atomic. Oh, this is Kirali, right? Kirali. I think we went over this. Anyway, we'll just touch base on this Kirali's letter. Yeah, thank you, interest. Plan to visit our institute. The conference webpage says the visit is planned on Saturday. The atomic is not closed at weekend. We can accept visitors only working days. You mentioned that Friday afternoon might be good for you. Atomic is located in Debrecen, east part of Hungary. Takes about 3 hours, and the 3 hours to get back to Budapest. Other solutions. So there's a visit Hungarian nuclear plant in Pax, sorts of far from Budapest, but at least open Saturday morning, closed Saturday afternoon on Sunday. So this is what she has suggested, Kirali. Probably should stay in Budapest, find something interesting. There are institutes and university departments dedicated to physics research. Please Google search to find some. You will not be welcome on Saturday, I guess. So Friday afternoon is the best option. There are very good museums in Budapest. So we don't have Friday afternoon. You see that our problem is that we don't have Friday afternoon because the whole conference goes the whole day Friday. So we only have Saturday. Then we have to stay over Sunday. I don't know what we can see. So other places we can see Saturday and Sunday, whatever is open. Then we have to stay Monday. Monday we have to stay over to visit these places. Tatamiki. I don't know about the seismology thing you are talking about, the Hundron. I don't know whether they are open Saturday. We have to figure out that. So we'll when I send the email, when you send me, I will ask them whether we can visit and on what day. Can we visit Saturday or something? Whether it's allowable. Otherwise, we have to do weekday Monday. We have to do Monday, and then we have to move on to CERN probably Monday night or something. So we can start either Tuesday or Wednesday. We can see it, and that's our plan. So on the way, also we have to find the transportation. What is the best way to do the transportation? Do we rent a van? Do we go by public transport? How do you move for example, from Budapest to Switzerland? How far do you have to fly, or can you go on a train? How far is it? You have to figure out all those things. When I go to AAA, I'll try to figure out what's the best way. I'm hoping to go next week or the coming week. Sometime coming week, I'll go and find out. So I'll get some information about that, whether they have any contact uh, to visit these places and what they suggest. So I'll get some information next week about that, hopefully. Uh, then we can plan. Our plan will be a little better. But they don't have group package, so I can probably get for myself and group. I don't know what they have. I have to find out. Otherwise, we have to find a way. I can give the information, and you can find out whether there's a group booking. That's possible for us when you come there. Uh, it'll be probably cheaper, or we have to rent a van or something like that, which hopefully will be cheaper. We can somebody can ride that, or if there's a proper public transportation, that may not be might be okay. But see, public transportation, if they have group people, we can share the same expense. You see that? So the expense will come down. But public transport, each person has to pay the ticket. I know there's a group ticket or not. So that's the difference. But of course, we have to see how much we can drive there. You drive, right? Laszlo, you drive, right? Do you drive? Laszlo,
I don't
do
know
you drive?
because I'm tired.
You drive? You drive car?
I can't try because I have a problem with my eyes.
Oh, okay. So then somebody else has to. Maybe Christian. I can try
Maybe
to get
yes.
a Christian, Christian or somebody or Christopher may be able to drive if we rent a car, rent van. But otherwise, we have to use public transport. You know, uh, either train or bus or something like that. But then going from Budapest, see, I was thinking that if you are trained, we can see the scenery, between Budapest and Switzerland. If it's not too far, we have to see how many hours it will take. Because they said for Germany, it takes about 5 or 6 hours for train. So it's not that bad. Then Switzerland is on this side, but I don't know how. Let me find out. I can Google it probably. Let me see. Uh, let me see. Okay. How far is it? Is it from Budapest to CERN? Switzerland. I think Switzerland. Okay. Oh, 700. Oh, wow. 786 miles. So, oh, the best way to fly takes 4 hours, cost $75 to $90. 5 hours it takes. I- Is there a train or U-rail? Okay, so it says Budapest was done 79. Train is 15 hours. Wow. Train costs a lot. So that's difficult. Even bus will cost a lot, $125. So the train are very expensive. So best way say is that uh, flying 5 hours, 79 to $250. Train is not too bad. Train to Vienna International Airport. Or fly. Train to Vienna International Airport. Shuttle bus. I don't know what this is. Let me see. Budapest, Hungary. Oh, that's different, I think. Uh, it's not that costly. I think. Yeah, I had to really find out from the AAA. Oh, you couldn't see, right? I probably could you see that what I was giving? I'm not sure. Talking about the Budapest CERN. So if we go by Urail, oh, this is different. Geneva. So there are 5 ways. Fly from Budapest International Airport. Flying is the best 5 hours, 79. Train it takes a lot, 15 hours. Bus is 19 hours. Train to Vienna International Airport. That's what I'm saying. You see, uh, shuttle bus, 20 hours. Wow. 20 hours, $127. Dollars. So shuttle bus is there. It won't be very expensive. I think let's, oh, it's about the same. That's okay. The flying probably is the best. Okay, so we have to check this one. Uh, the CERN. Once we get more information from the CERN, we'll get the idea. So those are some other things. So yeah, we have to really see. Let Christian said that this week he will be able to finish the booking, and after that we'll plan our post conference places. But in the meantime, you can send me the email address, so I will send the information to the Honran thing. The local science museum, I think it should not be a problem, right? The university going to the science museum that should be okay, right? because it's local. Yeah, but we have to see that they're open on Saturday. That's the only thing. Saturday and Sunday. Otherwise, we have to stay Monday. So we have to see what we can see on Saturday and Sunday. That's something you can think about what we can do on Saturday and Sunday. So then we'll go from there. But I'll also find out through the email how about the Hunron thing. So I think that way we'll proceed. We'll get more information I think each week, and then we'll go accordingly. Okay. So I think that sounds good. Is there anything else, Laszlo, you want to talk about?
Okay.
That's it? Okay.
No. Can
Okay.
I leave you because I'm
Yeah.
very tired.
Yeah.
Bye
We'll
bye.
see you next week. Yeah. Thank you.
Okay.
We'll see you next week. Have a nice
And
week. Thank you.
today evening I will send the director email address and the name. Okay. Bye bye.
Sounds good. Thank you. Have a nice
Thank
week.
you. Thank you.
Thank you.
Same. Thank you. Thank you.
Thank you very much.